All right. So factoring polynomials and double grouping. So basically, we're going to learn how to simplify polynomials by graphing them.
Good morning, family.
Oh, 1 second.
Greyhound family, please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Now the pledge to the Texas flag. Honor the Texas flag. I pledge allegiance to thee, Texas, one state under God, one and indivisible. Please remain standing for a moment of silence. Thank you. You may be seated.
Okay, sorry about that. So we are going to go ahead and learn how to factor polynomials, which basically means to simplify them using the greatest common factor and stuff like that. Okay, so here is an example of factoring. So we're going to factor out the greatest common factor for this polynomial. And then from doing that, we're going to be able to simplify. There's a series of steps that we're going to take. You may not get it the first time, but you're going to see that these steps are going to repeat as we go through each of these examples. And so eventually you're going to kind of see those steps come together. So let's go ahead and start. So factor the polynomial. Hold on. All right, there we go. 72x cubed plus 30x to the power of 9. So I'm going to factor this polynomial. The first thing I want to do is find the greatest common factors. How you find the greatest common factors is you want to take the factors of both 72 and 30. And basically finding the factors is just going ahead and identifying what can you add. What can you multiply together to give you 72? What can you multiply together to give you 30? And what you're looking for is how many prime numbers you can use. So for example, if I wanted to break 72 apart, I could do 2 times 36. 2 is a prime factor. Prime meaning it's only its multiple is itself and 1. So I can only multiply 1 and 2 to get 2. Now I can go ahead and break down 36 further. So I can go ahead and use 2 again. 2 times 18 gives me 36. Again, 2 is the prime factor, and so I can go ahead and circle that. Break 18 down further. 2 and 9. Again, 2 again is a prime factor, so I want to go ahead and circle that. And then lastly, I can't use 2 here, but I can use 3 and 3. 3 is also a prime factor because its only multiple is itself and 1. And so there we have listed out all the different prime factors that create this number 72, okay? And if you're not sure what prime factors are, I will go ahead and post a list of prime numbers. So you're looking for prime numbers, things that are only multiple by 1 in themselves. So the factors of that number is only 1 in themselves, so that you can reference if you aren't 100% sure. And so now I'm going to do the same thing for 30. 2 and 15 gives me 30. 2 again is my prime. Here I can't multiply 15 by 2, but I can multiply it by 3, specifically 3 and 5. 5 is also going to be a prime factor. And so there I have listed out all my factors of 72 and all my factors of 30. What I want to do is see what they have in common. I notice here that 30 has a 2. 72 also has a 2. I see here that 30 has a 3. 72 also has a 3. And I see here that 30 has a 5. Unfortunately, 72 does not have a 5, so those wouldn't be in common. However, what I notice is they both have a 2 and they both have a 3 that they can share in common. 1, 2, and 1, 3. okay? And so those would give me my greatest common factor. How do I find my greatest common factor? Well, I want to take those. They have 1, 2 in common and 1, 3 in common. And because they have more than one common prime number, we can multiply those together. And so that gives me 6. So 2 times 3 is 6. That tells me that 6 is going to be my greatest common factor. So the way that I find my greatest common factor is I want to see which prime numbers they have in common, 2 and 3. If I have more than one prime that they have in common, for example, if they only had 2 in common, then the greatest common factor would just be 2. But because they have 2 and 3, I have to go ahead and multiply this. So 2 times 3 gives me 6, okay? Now, how about these x's? What do I do with these x's? I have x cubed and I have x to the power of 9. Well, I can also derive a greatest common factor out of those. So I have x cubed, x 9. What you need to know is whenever you are comparing two x's together to find the greatest common factor, what you want to do is take the lowest, the one that has the lowest exponent. So 3 is obviously less than 9. And so you want to take the one that has the lowest. Now what I want to go ahead and do is I want to put these two together. So 6 and x cubed. That is my greatest common factor. Okay, so because I have x's, I also need to find the greatest common factors of those x's. I can't just leave those alone. Yes, I found the whole numbers, but I don't need to work with the x's. And whenever you're working with the x's, you're just looking for the smallest value. Which one has the smallest exponent? And then you're putting those together. Okay, questions about this? Questions about how to find the factors of 72 and 30, or how to find the greatest common factor of those x's? All right. So now our next step is to go ahead and take this information. So now I know my greatest common factor is 6x cubed. So this is step 1, deriving those greatest common factors. Now what I'm going to go ahead and do is write each term as a product where one factor is the greatest common factor. So I'm going to go ahead and do step 2. I'm going to take this equation just so we can look at it. And basically now I know that my greatest common factor is 6x cubed. So 6x cubed and 6x cubed. Basically, I'm taking away that factor, that greatest common factor. And so now what I want to go ahead and do is find out what can be multiplied by 6x cubed to give me my resulting value. What can be multiplied by 6x cubed to give me this? And what can be multiplied by 6x cubed to give me this? Well, we already have x cubed, which is here, so we don't need to do anything with the x's, but I have a 6 here and I have a 72 here. What times 6 will give me 72? The answer is 12. So there I created the factor for that one. How about this one? Here I notice I have an x cubed and here I have x to the power of 9. How do I get x to the power of 9? Well, I do x to the power of 6. Why is that? Because if I'm multiplying exponents, what I'm really doing is I'm adding them. And so eventually that would give me x to the power of 9, which is what I need right there, right? And now I have a 6 instead of a 30. How do I get 30 from 6? Well, 6 times 5. So there I have my factors of both of those expressions in that polynomial. Okay, and so now what do I do with this information? Well, now I do number 3. Step number 3, use the distributive property. So what I'm going to do is I'm going to put together like terms. I have a 6x cubed here. I have a 6x cubed here. Those are like terms, so I only need to write it one time. Here, however, I do not have like terms. I have a 12, and I have a 5x to the power of 6. What you're going to do, and you're going to see this repeat as we go throughout, is you're putting those together. So both of those black parts together by using addition. So you see how I've put those together? I put these together, these are the same. So I just have to write it once. Because those two are different, I just add them together. And so that gives me this, which is my resulting expression or my factoring of my original polynomial. So this is the steps you are going to take every time you want to go ahead and factor the greatest common factor out of a polynomial. Okay, and so we're going to see this happen again. Any questions right now? Questions? Okay. So again, these are the steps. Here's a more outlined set of steps, but it's basically the same thing. We group pairs that have common factors. We factor out the greatest common factor for each group. We use the distributive property to write the polynomial as a product of binomials, and then check it by multiplying. So basically, we're conducting the same steps. However, in this one, we're going to see, that those polynomials are going to have more terms. Here we only had 2 terms, right? 72x cubed plus 30x to the power of 9. Here we're going to work with more terms, but the only step we're going to add is we're just going to group them together. And so we'll see that right now. So factor by grouping. So we're going to go ahead and do this. So we're going to factor, and I'm going to write the polynomial for x cubed 14x squared plus 6x plus 21. The reason we want to first group, that's our first step here. That's the only new step that we've added. The reason that we want to go ahead and group is because it will make it easier for us to go ahead and factor out that polynomial. Remember that over here we only had 2 terms. Here we have 4 terms. And so grouping them would make it easier for us. So basically, by grouping them, it just means to split them up. So just splitting those things up. So I'm going to work with this, and then I'm going to work with this. What you see that happened when I group them is I've created 2 expressions, 2 polynomials that have 2 terms. And so it's easier for me to go ahead and factor those polynomials because they only have 2 terms. So the first step is basically to break up that longer expression into a shorter expressions, and then now I can go ahead and do those same steps that I did before. Okay, so we're going to look at this one first. Again, our first step is to find the greatest common factors for those whole numbers. So my whole numbers here are going to be 4 and 14. So I want to find the greatest common factor. So 4, 14. What can be multiplied together to give me 4? 2 and 2. Both of those are prime numbers. Again, I will show you the list of everything that is a prime number. I can actually show you really quick. Prime numbers. And so we're trying to identify these prime numbers. All these numbers that you see right here in yellow are going to be your prime numbers. Again, these numbers are prime numbers because if you were to multiply something to get this number, the only thing you can multiply is that number and 1. And so that's why we call them prime numbers. Here's another easy way for you to see all those different prime numbers. So basically, we're trying to identify what prime numbers we see whenever we factor out or factor that whole number. So 2 and 2, 2 is a prime number. Next one. 2 and 7. Well, 2 is a prime number, and actually 7 is also a prime number. You can only multiply 7 and 1 to get 7. So there I have all my prime numbers listed. I want to see what do they have in common. The only number they have in common is this one has 1, 2, and this one also has 1, 2. 4 doesn't have a 7, and so we wouldn't use that one. And so again, because they only share one common factor, which is 2, we would just use that. So 2. 2 is their common factor. If we had more than 1, for example, here we had more than 1 common, right? We had a 2 and a 3 in common, a 2 and a 3 in common. Then we multiplied those. But if we only have 1, then we're just going to use that prime factor. So in this instance, we only have 1, and so we're just going to use 2. Okay. Questions about this before I move on?
No, ma'am.
Okay. Perfect. Okay. And so now we're going to go ahead and work. We did those whole numbers. Now I still have these x's to deal with. I have to find the greatest common factor of those x's. So I have an x cubed and an x squared. Remember that I want to take the smallest. This is the smallest. It has the smallest exponent. 2 is smaller than 3. x2. And so now what I want to do is put those together. So that means the greatest common factor of this expression that I see right here is 2x squared. Okay, so I can't only find the greatest common factor of the whole number. I also want to find the greatest common factor of that x. And so in finding the x, you just use the smallest one. Okay, so that's solving for the first polynomial. Let's look at this next one. One has a 6, a whole number of a 6. The other one has a 21. And so I want to find their greatest common factor. 2, 3. 2 is a prime number. 3 is also a prime number. Let's look at this one. 3, 7. 3 is a prime number. 7 is also a prime number. I want to see what they have in common. The only thing they have in common is a 3. Because 3 is the only number they have in common, that's the number we would use. Now here, we see an x, but we don't see an x over here. And so because of that, we don't need to factor out any x's. We only factor out x's if both of them would have an x. So if this had an x over here, then we would factor it out. But just because only one value has an x, I don't need to factor out anything. So that just leaves me with a factor of 3. Okay, so basically what I've done is I've broken up that polynomial and then found the individual greatest common factors of each of those polynomials. And so right now I'm at 2x squared and 3. So how do I put that together? Well, this is my step number 3. Putting that together, I'm just going to write out that expression. Actually, let me take this real quick so that we can see what's about to happen. Now I'm just going to go ahead and write that expression. So I have a 2x squared and a 3. So 2x squared and a 3. Right, so I've written down the greatest common factor of each of those parts there. This one was a 2x squared. This expression was a 2x squared. Put that right there. This expression was a 3. Put it right there. Okay. And so now I'm going to go ahead and see what I have to multiply to that greatest common factor to get my original expression. So this first part, I noticed that I have a 2 here and I have a 4 here. And so therefore, I need to go ahead and multiply by 2. I notice here that I have an x cubed. Here I have an x squared. How do I get to an x cubed? X to the power of 1. So x, just x. Now the second part, I notice I have a 2 here, I have a 14 here. What multiplied by 2 gives me 14? 7. And I notice here I have an x squared and I have an x squared, so that means I don't have to do anything with that. Okay, how about this side? Here I have a 6, here I have a 3. So multiply by 2, 3 times 2 gives me 6. Here I have an x, here I don't have an x. I need to include that x, so I'm gonna put that there. Here I have 21, here I have 3. What times 3 gives me 21? A 7. Okay, so basically what I'm doing is now that I have my greatest common factors on the outside, what I need to identify is what I need to multiply by that greatest common factor to give me my original value. So 2x squared times 2x will give me 4x cubed. 2x squared times 7 will give me 14x squared. So basically I'm trying to figure out what do I need, what is my factor to give me my original expression. Here, 3 times 2x gives me 6x. 3 times 7 gives me 21. Okay, and so that's basically what I'm going to go ahead and do. And so therefore, that would represent, and I'll go ahead and write it again because I know you can't really see it. That would represent my simplified expression of that polynomial. Oh, actually, I'm skipping one step. Sorry. So now I want to go ahead and combine like things, sorry. So what you notice is that this is 2x plus 7, and this is also 2x plus 7. Well, that means I only have to write it once. All right, so I'm dropping that down. Very similar to what we did in the first problem. Here we notice we had 6x cubed once, or the same. Both of those were the same. And so if they're the same, I only have to write it once. But here I noticed that 2x cubed and 3 are not the same, right? Those are obviously not the same. And so I want to go ahead and put those together by adding them. And that's what I also did over here in this one. Right? I noticed that that 12 and that 5x to the power of 6 weren't the same, and so I went ahead and added them together. So if you do have like terms the same, they are the same, you only have to write it once. If you don't have like terms, then you only have to add it together. And so that's what I did here. And so therefore, this is my resulting expression, which is the simplified version of my original equation. Okay, questions?
No, ma'am.
No? Okay. Perfect. Let's see what's next. Okay. So that was grouping. And what we noticed there is we grouped by basically just dividing dividing that polynomial in half, right? 2 expressions on one side, 2 expressions on the other. What you have the option of doing is you have the option of regrouping to go ahead and still solve that expression, but maybe it might be easier in some instances to regroup it and do it in a different way. So I'm going to show you what that looks like. Okay, so let me break this apart. So our first option is to go ahead and just break the polynomial in half like that, and then solve for the greatest common factor of one side, the greatest common factor of the other side, and then put it together. Another option that you have, and what this is going to show you, is that you can go ahead, if for some reason you wanted to regroup that polynomial, you could go ahead and do so. And so regrouping it, for example, if I wanted to put this term and this term together, and this term and this term together, I could go ahead and do it. I could go ahead and regroup it to make it easier for me to solve if I wanted to do that. Either way, whichever way you group it, you're going to get the same resulting polynomial or simplified polynomial. So you do have that option to regroup. And so, for example, if I were to regroup using this, basically what this is telling me is that I have this polynomial that I'm going to factor, and then I have this polynomial that I'm trying to factor. Okay, and I can go ahead and quickly go through this. On this side, we want to see if there's a greatest common factor from those whole numbers. We have a 6, we have a 4. Again, I want to take out those prime factors. So 2 times 3, 2 is a prime factor, 3 is also a prime factor. 2 times 2, 2 is a prime factor, 2 is also a prime factor. What do they have in common? They have in common 1, 2. And so the greatest common factor of that is just 2. Here I notice that I have 2 x's. I have an x cubed, and then I have just a regular x. When I have 2 x's, I want to take the lowest of those 2 x's. So this x is the lowest. It has an exponent of 1. The other one has an exponent of 3. 1 is less than 3. And so, therefore, I have a greatest common factor of 2x. So that's that side. Now this side. Again, I want to do the whole numbers. -3, negative 2, negative 3, negative 2. I want to take out those prime factors. So if I did negative 1 and 3, negative 1 is a prime, 3 is a prime, negative 1 and 2, negative 1 is a prime, 2 is a prime. Right? Those things can only be multiplied by 1 in itself to give you that expression. What do they have in common? This negative 1. And so I would write that there. Do they have any x's? Well, yes, one of them has an x, but the other one doesn't, and so I wouldn't have to factor out any x's. Okay, so now I have my two greatest common factors, 2x and negative 1. I want to go ahead and write that next to those expressions. So I'll take this. Let me put it closer together just so we can see it. Okay, the greatest common factor of this side was 2x. The greatest common factor of this side was negative 1. Now I want to see what I have to multiply together to give me my original expression. So I have a 2, I have a 6. 2 times 3 gives me 6. Here I have an x, but I need an x cubed. So I want to do x squared, because that will give me x cubed. Plus, here I have a 2, here I have a 4, so 2. Here I have an x, and here I have an x. So I can just leave it like that. So I don't need to multiply any other x's to give me just that regular x. I already have it. Now this side, I need a negative 3. And this one doesn't have an x, but this one does, so I need to include the x. X squared. And here I have a negative 1 and I have a negative 2. So plus 2. Again, what I'm doing here is I'm trying to identify what do I need to multiply together to give me this expression. So I multiply that together, gives me that expression. 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 Okay, so that's basically what I'm going ahead and showing here. And so now I'm just going to put together, if I have common ones, do I have any common ones? Well, I have 3x squared plus 2. Here I have 3x squared plus 2. That's not supposed to be a negative. 3x squared plus 2, 3x squared plus 2, those are in common. So I'm just going to drop those down once. If they're in common, I only need to write it once. But here again, I have different ones. I have a 2x and I have a negative 1. If they are different, then I'm adding them together. So 2x plus negative 1. Or I can write it as 3x plus 2, 2x minus 1. And so that would represent my factored polynomial. Okay, so if you wanted to regroup it, you could go ahead and do that if you think it's easier for you to solve. Either way you did it, you would get the same result or the same expression. So it's up to you whether you want to regroup it or not. Sometimes it's easier to do so, sometimes it doesn't really matter. In this instance, it wouldn't really matter, you would get the same expression. Okay, but again, you are following those same steps for every type of factor you are doing. Okay. All right, let me see. What next? Okay. Let's briefly review this. So using the additive inverse to factor by grouping. So there are some instances, for example, if I had this expression x cubed minus 2x squared minus 3x plus 6. There are some instances in which you will have an expression which is actually easier for you to go ahead and use the additive inverse to solve. So there are some instances in which that is the case. So for example, if I had this expression, I would basically, again, break it apart, and then I would solve for the greatest common factor of each of those parts. Okay, and when I do that, what I'll notice is that I don't get a common factor, so I can go ahead and show you briefly. So say I want to factor this expression, how it is. So this goes over here, this goes over here. That gives me two polynomials to work with. Okay. Here I want to see my greatest common factors. Here I have a whole number, but here I don't. So I can't take away a factor of a whole number. Very similar to if I have an x on one side and I don't have an x on the other side, I don't want to take an x out. So because I have one whole number, then another expression that doesn't have a whole number, I don't want to take any expressions out. But what I notice is that I have an x cubed and I have an x squared. And so there I can go ahead and factor. X cubed, x squared, I want to take the lowest. So x squared. So that would be my factor of that expression. Let's look over here. Here I have a -3 and a 6. So I want to go ahead and identify the greatest common factor there because I do have two whole numbers. -1 and 3. -1 is a prime factor, 3 is a prime factor. 2 and 3. 2 is a prime factor and 3 is a prime factor. What do they have in common? This expression 3. So 3. Do they share common x's? Well, no. One has an x, one doesn't, and so I don't have to factor anything out. So in this example, this one had an x and this doesn't, so I don't have to take out an x. And while here, this one has a whole number, this one doesn't, so I want to take out a whole number. Okay, so there I've identified all my factors. Okay, and so now I want to go ahead and take my equation and break that down. So the greatest common factor on this side was x squared. The greatest common factor on this side was 3. And so I want to go ahead and identify what I need to multiply to give me my original expression. Here I need to multiply by x to give me x cubed. Here I need to multiply by 2, or -2 to give me 2x squared, sorry. Here I have a 3, but I need that x. More specifically, I need a -x, so I'm going to multiply by -x. Here I have a 6, here I have a 3, so I'm going to multiply by 2. Okay, so those are my simplified expressions, and now I want to see, do I have any like terms? What I notice is I do not have any like terms, and so because of that, what this expression would look like, remember, if I don't have like terms, then I'm going to write that expression by adding it together. If I do have like terms, then I'm only going to write it once. But because here I don't have any like terms, then what I get is this expression, which isn't really that simplified. And what you'll also notice is that these two are opposites of each other. This one has a positive x. This one has a negative x. This one has a -2. This one has a positive 2. So they're opposites of each other. And so I don't really get much of a simplified expression. However, if I did want to get a simplified expression, I could actually go ahead and do that. And the way I do that is I want to go ahead and use the additive inverse. So I want to take this as the original expression right here. And what I want to use is the additive inverse. So give me 1 second. So I'm going to add the additive inverse. So basically that means is I'm going to take this and add the additive inverse. Give me 1 second. Make sure I'm doing. So I'm going to add the additive inverse. So I'm changing these signs. So that's a positive, and now that's a negative. So I've changed the signs, right? That's adding the additive inverse. And so now whenever I go ahead and break this apart and find the factors, what I get is a completely different expression. In fact, my expression will have a common point. So if I factor this, again, I don't have any like whole numbers. I have x cubed and I have x squared. So because I have common x's, I want to take the smallest of them. So this is my factor here. Now this side, I have two whole numbers. So two whole numbers, -3, and this is actually a -6. Now I can go ahead and again take out the factors. -3 is a prime number, 1 is a prime number. -3 is a prime number, and 2 is a prime number. See what they have in common? Now they have in common a -3. Where over here they had in common a +3. And so now because they have in common a -3, now what you're going to see is I'm going to have some commonality. Okay, and I don't have to take out an x because I only have one x, so -3. So now I want to take those expressions and factor them out further. I'm going to put it together just a little. Okay, so here I took out an x squared. Here I took out a -3. And now I want to go ahead and see what I have to multiply together to give me my original expression. Here I'm going to multiply an x squared plus x, or x squared times x gives me x cubed. Here I need a -2. And I already have an x cubed, so I don't need to multiply it by any other x. There's my first expression. Here I have a -3. I already have a -3, but I do need to have that x, so I'm just going to add that x there. -3 and -6. What times -3 gives me -6? The answer is -2. And so there I have gone ahead and factored out my expressions. And what I notice is now I have like terms. And so those I'm not going to write 2 times, I'm only going to write once. Then I have unlike terms. If I have unlike terms, then those I'm adding together. And so what you notice is by using the additive inverse, what I've resulted in is 2 completely different expressions. This one is more simplified than this one. And so sometimes it's easier to use the additive inverse to go ahead and factor your polynomial out. Okay, but that's using the additive. Okay, so here are the different steps that we use to go ahead and factor polynomials. We want to group polynomials with common factors. This is if our polynomials have more than 2 terms. Basically, what we want to do is factor it out to where we only have 2 terms on each side. For example, like this, we have 2 terms broken up, 2 on this side, 2 on this side. So you want to go ahead and group them so where you have common terms, if you do have more than 2 terms. And then you're going to factor out the greatest common factor for each group. If there's 2 whole numbers, you're factoring out a whole number. If there's 2 x's, you're factoring out the smallest x. And then it basically use the distributive properties. You want to see what do I have to multiply to the greatest common factor that I've taken out to give me my original expression. And then if you want to, you can check by multiplying. So basically, now that you have your expression, you can go ahead and multiply those 2 together and see if you get your original, where you started out. Okay, questions?
No, ma'am.
And then we'll go over example problems tomorrow. I will go ahead and upload basically a shortened version of everything we've gone over today in just a bit. So if you want to look at that, just keep an eye out for that. Okay? All right. If there's no other questions, I will see you guys tomorrow for practice problems. Have a good day, guys. Bye.
Bye, miss.
Bye.